Hi, this session is on our Surd revision. So just going over all of the questions on that revision sheet. So with the first question, it asks us to explain the difference between a rational and irrational number, okay? And there are basically some important keywords or points that we need to write down and to show the difference between these two. So I've quickly written up my own understanding of this. So I've just split it into two. So for rational numbers, the most important thing is the decimal either terminates, so stops, or has a recurring pattern. Okay, and I couldn't fit it in, but what the other important point is, it can be turned into a fraction. Okay, that's another important point. Rational numbers can be turned into a fraction, whereas irrational, okay, the decimal is infinite with no recurring pattern. So it's sort of the opposite. But also it cannot be turned into a fraction. So no fractions when it comes to irrational numbers. And that's pretty much it. So put this into your own words and show the difference between the two. Now question 2 says, state whether each of the following number is a surd. And the best way to do this, some of them you can sort of tell, like for example, with A, the square root of 25, I know it's not a surd because the answer is a whole number. It's 5. But if there are ones that are looking confusing or tricky to work out, put it in your calculator. And if you end up with a decimal that's irrational, no pattern, then it's a surd. So let's try some of these. All right, with B, so we know A, it's not a surd because 5 is a whole number, that's rational. With B, a trick is you can go 20 times 20, which gives you 400. And then the square root of 400 is just 20. But whenever you see a square root and a squared, they actually cancel out each other. And that's a skill we'll be learning later on when we learn Pythagoras. So in this case, this will equal just 20. So this is also not a surd. So no surd, not a surd. All right, with C, a number times itself 3 times to give us 343. If you can't think of a number, if you're in a hurry during a test, just put it in your calculator. So you should know how to put this into your calculator, depending on what model you have. If you're not sure, please make sure you find out. And I put this in my calculator and it gives me a whole number 7. So this tells me that this is also not a surd because it's a whole number. And the last one, a number times itself 4 times to give me 32. Just like I'm in a hurry, I can't think of a number, I'll put it in my calculator. So 4 square root 32, and it comes up on my calculator, it comes up with this decimal 2.3784142, and I can tell straight away this is a surd because there is no pattern and it's irrational. So we can say yes, this is a surd. Okay, and that's pretty easy. So with these ones, just use your calculator. The next part of 2 is just here, and it asks us to classify each of the following numbers as rational or irrational, okay? And some of these examples may be surds, but we can see some aren't. And we know a surd is a number that has to have the radical sign somewhere. So let's have a look and see at these examples. Okay, so with the first one, I look at this number and straight away I can see a recurring pattern. We know we can write this as 6.2 with a little dot on top. So therefore this is a rational number, okay? It's rational because this can be turned into a fraction and there's a recurring pattern, which is in this case 2. B, I know B is a surd because the square root of 8, it's an irrational number. If I put the square root of 8 in my calculator, it'll give me, 2.828 and so on. So this is irrational. It's an irrational number because the decimal of this answer, there is no pattern and it goes on forever. So with C, I've got 4 over the square root of 16. Now I can see the square root of 16 is actually not irrational. It's not a surd because the square root of 16 is 4. So what I end up with is 4 divided by 4 or over 4, which gives me 1. 1 is just a whole number, so this example is rational. We're done. With D, I have a look at this. I've got 5.8685354015, and it goes on. So from what I can tell, there is no pattern. There's no recurring pattern, so therefore this is an irrational number based on the information that is given to me. And with E, straight away, I know E is rational because I've got 0.2, a terminating decimal, divided by 7. Okay, you can put that into your calculator, 0.2 divided by 7, and it gives me 0.028571 for 2857. I can see a pattern that's reoccurring, and therefore it's rational. But there are no irrational numbers here. And rational numbers can also be negative as well, okay? Okay, question 3 now asks us to simplify the following surds, we think they're surds. Let's have a look. So, with the square root of 32, yes, I can't think of a number times itself twice to give me 32, but we know that to do this, we have to use our perfect squares. If it helps, you can write down your perfect squares somewhere on the side. So I'll just do mine here to start me off. Okay, so some perfect squares. And let's see if there are any factors listed here that divide into 32. Now I know that 4 times 8 gives me 32, but I can tell that there may be a higher perfect square. So let me try, well, 9 can't go into 32. What's 32 divided by 16? It gives me 2. So I'm going to use that to save me working out. So I know that 16 times 2 is 32. You can separate them, but I'm going to skip that step. So the square root of 16 is just 4, and I'm left with the square root of 2. Okay, you can separate them, but I think we're at a stage now where we know what to do, and that's simplified. I can't go any further. My 2 is simplified furthest as possible. All right, the square root of 125. Let me just check. Is 25 times 25, what does that give me? No, it doesn't give me 125. So I have to try and simplify this. Now, if I go 125 divided by 25, it gives me 5. So I know that I can use that. 25 times 5 gives me 125, and 25 is a perfect square. So I have room to separate them here, if you prefer doing that. And the square root of 5 is 5 times the square root of 5. And that's our answer. Okay, so number 4. Once again, we are simplifying these surds. The only difference is there's whole numbers on the outside. That's fine. We know there's an invisible times in between there. So this 6 times the square root of 8, the 6 just stays out there for a second. And now let's simplify the square root of 8. So I know that 4 times 2 will give me 8. And 4 is a perfect square. The square root of 4, if you separate them, is just 2, a whole number 2. And we're left with the square root of 2, still there. And then 6 times 2 is 12. I'll just put it up here. Square root 2. So that should have been your answer. With B, we've got minus 2 times, and a perfect square that goes into 50, I know that 25 times 2 gives me 50. So the square root of 25 is just 5, and then the square root of 2 is stuck there. So minus 2 times 5 is minus 10, square root 2. That's your answer. Okay, number 5, I just managed to squeeze the bottom one in. So I'll tell you, if you can't understand, that's 3 square root 10, but you can look at your worksheet. All right, so the first one, 5a, I can see the operation now is addition. So we're simply adding like terms, okay? So it's all positive, so it's pretty straightforward. And I can see that every single one is a like term. All have the square root of 3. That's a surd, and it can't be simplified further. So now I just count how many of these do I have. So 5 plus the 1 there is 6, and 6 plus 2 is 8, square root of 3. That's it, we're done. We've got 8 of those. With B, because I'm starting to see negatives and positives, a trick is always circle to your left to show clearly what the operation is. Is it a positive or a negative? And that's just a positive there. And now I also notice that I've got different like terms. So I'm going to first highlight the surd of square root of 5. That's a square root of 10, and there's another one here. So these two are like terms. I'll do that first. So what is positive 10 minus 7? Well, 10 minus 7 is just 3, and I've got the square root of 5 there. And that's done and taken care of. And then I can change my color for the other like term. I've got the square root of 10 and the square root of 10. And once again, I've got positive 2 plus 3. So 2 plus 3 gives me a positive 5, and then square root of 10. I can't simplify anything further, and we're done. Okay, number 6, the operation we are dealing with is multiplication. Okay, and we know the rule or the law. When multiplying surds, you simply multiply outside with outside and inside with inside. So now the surds, they will be changing. And then of course simplify further if you can. So here I've got 5 times 7 under the square root, which gives me 35. And check, is there a perfect square that can divide into 35? So if you're unsure, you can just divide 35 by 4. Maybe that might work. No. 35 divided by 9. No, that doesn't work. And then eventually I can realize that we stop here. We cannot simplify that anymore. There's no perfect square that divides into 35. And okay, so with B, once again, there are no negatives in these ones, so my answer is going to be positive. That's really your first check. We're multiplying. And now let's multiply the outside numbers. So we've got 6 times 3, which is 18, and square root. All right, we've got 5 times 10 is 50, and 50 times 2 is 100. Okay, so we're almost there, but I can see the square root of 100 is actually going to give me 10. It's a perfect square. Okay, 10 times 10 is 100. And then 18 times 10, just add the 0, gives me 180. And we're done. Okay, with question 7, this is the hardest part students find when it comes to working with surds, and that is division or fractions. And this basically involves your fraction skills. So if you're lacking in that area, this is something we need to practice because it's really important in mathematics. Now with 7a, you notice we have the division symbol. Now you can work this out quite easily the way it is because just like multiplying, we divide the inside numbers with each other, or we divide the outside numbers with each other. And this one's pretty easy. 18 divided by 2 is just 9, or the square root of 9, and the square root of 9 gives us 3 because 9 is a perfect square. So that was our answer. But the other way that I prefer doing this, when they're not so easy, is writing it like this: the square root of 18 divided by the square root of 2, and simplifying it in fraction form. And then 18 and 2, we also know that special rule that if you can combine them under the same square root, you can do that and it might help you with your working out. And then I can divide 2 by 2 and 18 by 2, and it leaves me with the same thing, which is 3. But keep that in mind. So with B, I might put it in fraction form because it's starting to look a little bit complicated, but you can work it out the way it is, that's fine. I'll just change my color. So first I will simplify outside values. Because I see them, I can see 2 values exactly the same, 8 and 8, it's gone. It's really just a 1. Okay, and now I'm left with the surd. I've got 10 here and a 5 here. Well, 5 divided by 5 is 1, 10 divided by 5 is 2. So what I am left with is 1 times square root of 2 is just a square root of 2 over the square root of 1. Now don't stop there. We know the square root of 1 is a perfect square. 1's a perfect square. This just equals 1. So your final answer should look like this: the square root of 2. Okay, so 8a, once again we are dividing. I am going to put it in fraction form because that's how I like doing it, and you can't really make a mistake. Okay, so working with my outside values, I've got 8 and 16. The highest factor of 8 and 16 I can think of is 8. So if I divide 8 by 8, it's 1. 16 divided by 8 is 2. And that's done. And now the same thing in here. I've got 18 and 6. The highest factor of 18 and 6 that I can think of is 6. So divide them both by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. So let's write what I've got left. So there's a times here. I've got 1 times the square root of 3, which is just the square root of 3. And then 2 times 1. And now have a look at this. Is there anything else that I can simplify? No, there isn't. So that's our final answer. Okay, this one is in fraction form already for us, which is good. We'll just change the color. Now, I have to just simplify 50 and 60. And this is really easy. Just chop the zeros off or divide by 10 and we're done. So I end up with the square root of 5 over the square root of 6. Double check, can we simplify the square root of 6 any further? No, we can't simplify the square root of 5. And that should have been your final answer. Okay, with 8c, this one is just like the other questions, and we know that this can also be written as the square root of 5 over the square root of 25. They have just done that extra step for you. So just don't be confused if you see that big square root sign. All right, so simplify 5 and 25 and we're done. You can use either one, but I'll stick with the one they gave us. So I know just divide them both by 5. That's a 1, and 25 divided by 5 is 5. So I end up with square root of 1 over 5. And the reason we shouldn't, don't stop here, put it back into this form. So what I mean is we have the square root of 1 now over the square root of 5. So let them have their own square roots or their own radical sign. And that's because now the square root of 1, I know, is just 1. So your final answer should always be as simplified as possible, which is now 1 over the square root of 5. That should have been your answer. Okay, so with this question, it should be 8D. I just realised they're not numbered properly, so sorry. Once again, we are multiplying. There are quite a few fractions involved, and this is where students tend to get confused, but it's really easy. Remember, simplify anything from the top and the bottom. So it can be diagonal, it can be vertical, but remember, simplify the outside with the outside, and then simplify the inside with the inside. So I want to do, there's heaps of ways of approaching this. I can see a lot of, for example, perfect squares, or I just wrote this one wrong. This should be the square root of 4. Okay, that should be, just change it so we don't get confused. All right, that looks better. Oh, and sorry, one more, I'll just fix this question up. All right, that's done now. It's the same question. So I'm going to just simplify outside numbers first, if I can. So I've got 12 and 4. So 12 and 4 can be simplified. 4 divided by 4 is 1, and 12 divided by 4 is 3. I can't simplify the top 3's because they're both on top. So my outside is done. If you want to rewrite it, you can, but I might keep going because it's not too messy right now. Next thing I see is the exact same number, which is the square root of 2, gone. Square root of 2 is gone. Now the other thing I'm going to do, we can't simplify the 9 and 9 because one's a surd and one's a whole number, so be careful there. But I can, I might just rewrite what I have left. So sometimes it is a good idea to just stop and rewrite so it's not getting confusing. All right, now I'm going to try and simplify my surds, and I know that the square root of 4 can be simplified with the square root of 8. So 4 and 8, 4 divided by 4 is just 1, and 8 divided by 4 is 2. And then the other thing that I can do, I've got no more square roots on the bottom to really simplify with the 9, but the square root of 9 is just a whole number 3. So now I've got 3 over, the square root of 1 is just 1, times 3 over 1 times 3 square root 2 over 9. All right, so I'm nearly there. And now that 3 is a whole number, I can simplify the 9 and 3. That becomes a 1, that becomes a 3. And go one more step, I've got a 3 on top and a 3 on the bottom. So that simplifies to 1, and that simplifies to 1. And I think that's all we can do when it comes to simplifying. So if we multiply this out, I'll put the answer on top. I've got 3 times 1, which is 3, times 1, which is just 3. But then also I've got the square root of 2 sitting there. Good. Over 1 times 1 times 1 times 1 is just 1. So your final answer, I'll just rub off the bottom bit. That can be invisible. That's your final answer, 3 square root of 2. All right, so the last one, number 9, it looks, I guess, complicated, but it's really easy. And like I said, there are different ways of approaching this. And what I'm going to do as my first step is cross off anything that is the same on the top and bottom. So starting with the outside numbers, 5 and 5 is just 1. Done. I also have 7 here and a 7 there. That's gone. That's it for my outside. For the surds, I've got a square root of 2 that's gone and a square root of 2 that's gone. There's nothing else that's exactly the same. So I'll stop there and write down what I have left. So I've now got the square root of 10 times the square root of 16 times 9. We know that's a 1 there, and 9 times 1 is what? 9. Times the square root of 3 over, that's just a 1. We've got the square root of 4 times the square root of 21. All right, so now, once again, you can approach this in a different way. What I'm going to do is try and simplify the surds now with each other. I can, for example, go the square root of 4 is 2, but I think a better way is dividing the 4 and 16 by a factor of 4. Okay, so that's just 4 divided by 4 is 1. 4 divided by 16 is 4. So the square root of 4 is on top. And also 21 and 3. 3 divided by 3 is 1. 21 divided by 3 is 7. And I don't think I can simplify anything else. So what I'm left with is the square root of 10 times the square root of 4 times 9, and then times just the 1 there. All over the square root of 7. So I didn't have to write that 1 there. Rub that out, because we know that's just invisible. All right, and now I can also simplify the square root of 4, which is just a whole number 2, because that's a perfect square. And now let's multiply everything out. So I've got 2 times 9, which is just 18, times the square root of 10 on top, all over the square root of 7. And have a look and see, is there anything else that we can simplify? 10 can't be simplified further, 7 can't. So that's our final answer. So hopefully that's helped you, and the more you practice, the better you become. But remember, these kind of questions, they're just fraction skills. Thank you.